Hi everyone, I am Dr. A. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Sensors and Actuators. Subject code is AU3008. Unit 4 is Automotive Actuators. Under this we are going to see the topic Working Principles, Construction and Location of the Solenoid Actuator. Solenoid actuator. Solenoid actuator is an electromechanical device that converts the electrical energy into the linear mechanical motion. It consists of coil of wire and movable core, often called plunger. The solenoid actuators are widely used for tasks that require a linear push-pull motion, such as in locking mechanisms, valves, automatic systems. Structure and components of the solenoid. Coil is the this is the coil of wire wound around the core. When an electric current passes through the coil, it generates the magnetic field. Core. The core is the ferromagnetic material, usually iron or steel, that concentrates the magnetic field produced by the coil. Plunker. A movable piece of ferromagnetic material that is attracted to the core when the coil is energized. Housing. The protective casing that encloses the coil and plunker. Spring. In many designs, the spring is used to return the plunker to its original position when the coil is de-energized. Magnetic field produced by the solenoid coil. When an electric current is passed through the coil winding, it behaves like an electromagnetic plunker, which is located inside the coil, is attracted towards the center of the coil by magnetic flux set up within the coil body, which in turn compresses a small spring attached to one of the plunker. The force and speed of the plunker movement is determined by strength of the magnetic flux generated within the coil. When the supply current is turned off, the magnetic field generated previously by coil collapses and energy stored in the compressed spring forces the plunker back out its original rest position. This back or forth movement of the plunker is known as the solenoid or stroke. In the other word, the maximum distance the plunker can travel in either in or out direction, for example 0 to 30 millimeter. Working of the solenoid actuator. When the current flows through the conductor, it produces a magnetic field. The magnetic flux produced by the coil result in establishing north and south pole in both core and plunker. The plunker is attracted along the lines of force to a position at the center of the coil. Working of solenoid actuators. The de-energized position of the plunker is partially out of the coil due to the action of the spring. When voltage is applied, the current through the coil produces a magnetic field. This magnetic field draws the plunker within the coil, resulting the mechanical motion. The effective strength of the magnetic field on the plunker varies according to the distance between the plunker and the core. While a solenoid is a control device, the solenoid itself is energized by some other control device such as switch or a relay. One of the distinct advantage in the use of solenoid is that a mechanical movement can be accomplished at the considerable distance from the control device. Solenoid also provide a means of controlling high current with a low current switch. Types of solenoid actuators. Solenoid actuators are the electromechanical device that uses the magnetic field to generate the linear or rotary motion. There are several types of the solenoid actuators classified based on their motion, structure and applications. Here are some of the key types. Linear solenoids, push-pull, pull type and push-pull type. Rotary solenoid. Designed to convert the electromagnetic force into rotary motion. These solenoids rotate the specified number of degrees upon the activation. They are often used in the positioning device, switches and mechanisms that require a rotational movement. Coil. A coil is the electromagnetic that generate the magnetic field when energized. Plunker. The plunker is movable part that is attracted to the magnetic field generated by the coil. Spring. A spring is provided restoring force to return the plunker to its original position when the power is removed. Tabular solenoid. Cylindrical in shape, tabular solenoids have a high power to size ratio, making them suitable for applications requiring powerful linear motion in compact space. Other type of solenoids are C-frame solenoid, D-frame solenoid, open frame solenoid, latching solenoid, proportional solenoid, holding solenoid. Applications, it is mainly used for the stator motors, door locks, valves, robotics, washing machines, etc. Thank you.